Isn't it just amazing when you think about paleontology? It's like being a detective, but for, millions of years ago.
It really is. You're piecing things together from tiny clues.
And today, we're diving into one of those cases, a dinosaur called Australodocus.
Ah, yes, Australodocus. And for you listening, this is a really great example of how our picture of the past can change. It's been a bit of a journey figuring this one out.
Exactly. So our mission here is to sort of cut through the jargon, look at the science, and figure out what we actually know about Australodocus. Its discovery, that name, and this whole debate about where it fits in the family tree.
Basically, a quick way for you to get up to speed on this pretty interesting dinosaur.
And we're sticking to the source material, right?
Yeah,
The actual scientific papers.
absolutely. We're looking at what the paleontologists themselves published, their findings, their analyses. That's the core evidence.
Okay, great. So let's start with the name then, Australodocus. It sounds, well, significant. What does it mean?
It does sound quite grand, doesn't it? Well, it breaks down from Latin and Greek. Australis means southern,
Okay.
and docos means beam. So, southern beam.
Why beam and why southern?
Good questions. The southern part is because it was found in the southern hemisphere, specifically Africa, which was part of Gondwana back then. The beam part, the docos, connects to Diplodocus.
Ah, okay, like the famous long-necked one from North America.
Exactly. The initial thought was that Australodocus was a southern cousin, a relative of Diplodocus, hence southern beam.
Got it. A geographical hint and a link to a known dinosaur. That makes sense. So when and where did this southern beam actually turn up?
The discovery was quite early, actually, in 1909.
Wow, over a century ago.
Yep. And the location was the Tendaguru Formation, specifically the upper dinosaur member of that formation, in what's now the Lindi region of Tanzania.
Tendaguru. That name pops up all the time with late Jurassic dinosaurs in Africa, doesn't it? Sounds like a major site.
Oh, it's huge. A real treasure trove from that period. It's given us so many incredible dinosaurs, especially sauropods.
Like who else? Who are Australodocus's neighbors?
Well, you had giants like Giraffatitan. You might remember that one used to be thought of as an African species of Brachiosaurus.
Right, right.
And then there's Wimweracaudia, Genentia, Tenaguria, Torniaria. I mean, it paints a picture of a really diverse sauropod fauna down there.
That's quite the lineup. So what did they actually find of Australodocus back in 1909? Was it a full skeleton?
Not quite, unfortunately. The key find, the holotype specimen, that's the one the species is officially based on, consisted of 2 neck vertebrae. Just 2.
Only 2.
Yes. And apparently they were found as part of a series of 4, but, and this is really quite sad, the other 2, and potentially other bones found with them, were destroyed during World War II.
Oh, wow. That's a huge loss. So our whole understanding is based on just 2 bones.
Primarily, yes. And that scarcity of material is really central to why there's been so much debate about it. It leaves a lot open to interpretation.
I can imagine. Now, the species name is Australodocus bohedi. What about the bohedi part? Is there a story there?
There is, and it's a good one. It honors Bohedi bin Amrani. He was a crucial member of the team, the native crew supervisor and chief preparator for those German expeditions. His skill was apparently indispensable.
That's fantastic. It's great when the people who did the hard work on the ground get recognized like that.
Absolutely. It's an important acknowledgement.
Okay, so they have these 2 neck vertebrae, and the initial conclusion was it's a diplodocid, like Diplodocus. What pointed them in that direction? What features?
The main thing was the presence of bifurcate neural spines on those vertebrae.
Bifurcate neural spines. Can you break that down?
Sure. Imagine the bony spine sticking up from the top of each vertebra. In many diplodocoids, that spine is split or forked at the top, like a Y shape.
Okay, like a double spine on top.
Exactly. And seeing that feature on the Australodocus vertebrae was a strong indicator, a kind of hallmark of the diplodocoid group. So based largely on that, Christian Reams formally described it in 2007 and placed it within the Diplodocidae family.
So the forked spines were the smoking gun initially. But as you hinted, things got more complicated. People started thinking maybe it wasn't a diplodocid after all, maybe something else entirely.
Precisely. The story didn't end there. Later studies, particularly work led by John Whitlock and his colleagues, started to challenge that diplodocid classification.
Okay, so what did Whitlock and the others propose instead?
They looked closely at the anatomy again, comparing it more broadly, and argued that Australodocus might actually fit better within a different, larger group called titanosauriforms.
Titanosauriforms.
Yeah.
That includes really massive titanosaurs, right. And Brachiosaurus.
Yes, exactly. It's a huge group that includes the titanosaurs, which were dominant in the Cretaceous, but also their earlier relatives like Brachiosaurus. So this was suggesting a very different branch of the sauropod family tree for Australodocus.
Wow, that's a big jump. From a Diplodocus relative to maybe a Brachiosaurus relative, what did they see in those two bones that made them rethink it so drastically?
Well, they looked beyond just the bifurcate spines, examining other, perhaps more subtle details of the vertebrae shape and internal structure. They found features, a combination of characteristics that seem to align more closely with what you see in titanosaur forms than in typical diplodocids.
Hmm. It shows how looking at the same evidence through a different lens or with more comparisons can lead to different conclusions.
Absolutely. And it ties into broader patterns, too. You mentioned the Tendaguru Formation.
Yeah, the African site.
Right. And then there's the Morrison Formation in North America, roughly the same age. The interesting thing is, the Morrison seems packed with diplodocoids, while Tendaguru has more macronarians, that's the group, including titanosaurs and brachiosaurs.
So different continents, different dominant sauropod types.
It seems that way. And some scientists think this might reflect the environment. Maybe Tendaguru was more forested, favoring macronarians, while the Morrison was more open plains, better for diplodocoids.
And if Australodocus is a titanosaur form.
Then it fits much more neatly into that Tendaguru pattern, doesn't it? Makes more ecological sense, perhaps.
Okay, that's a fascinating angle. But the story doesn't stop there either, does it? I get the feeling this classification ping-pong continued.
You're right, it did. Science rarely settles instantly. In 2015, another major study, this one by Emmanuel Schopp and his team, took another look.
And what did they find? Back to the diplodocids.
Sort of. Their analysis actually suggested putting Australodocus back within the Diplodocidae family, but specifically in a subgroup called Diplodocinae. They proposed it might be a close relative of dinosaurs like Supersaurus and Denerosaurus.
Okay, so back towards the original idea, but maybe a bit more specific. What was their reasoning?
Their phylogenetic analysis, basically using computers to compare lots of anatomical features across many dinosaurs, grouped it there. But, and this is important, they themselves noted a caveat.
Oh, that was the catch.
They pointed out that their analysis didn't include a very wide range of titanosauriforms for comparison. And Australodocus has this particular internal bone structure.
Uh-huh.
It's called symphospondylus. Think of it like spongy bone with lots of air spaces inside. It makes the bones lighter but still strong.
It was spongy bone.
And that symphospondylus structure is very common in titanosaur forms, but less so or different in diplodocids. So because Australodocus has this structure, and their analysis didn't have many titanosaurs to compare it with, they flagged their own diplodocid placement as potentially less certain.
Ah, I see. So that spongy bone structure kept pulling it towards the titanosauriforms, even when other features pointed elsewhere. It's a bit of a contradiction.
Exactly. It's a key feature that complicates things, which leads us to yet another analysis.
There's more. Okay, let's hear it.
Where recently, in 2019, Philip Mannion and colleagues focused specifically on that symphospondylus structure. Their research suggested Australodocus might be what's called a non-titanosaur symphospondyle.
Okay, what does that mean?
It means it belongs to the larger group Symphospondyli, which includes titanosaurs, but it's not a titanosaur itself. It's maybe a more primitive member of that broader group. They even suggested it might belong to a family called Euhalopodidae, which contains some early Asian sauropods.
So not quite a diplodocid, not quite a titanosaur form like Brachiosaurus, maybe something in between or on a side branch related to Asian forms.
That's one interpretation, yes. It places it sort of basal within that Symphospondyli group outside the main titanosaur radiation and also outside Diplodocoidea.
Wow. What a ride for poor Australodocus. Diplodocid, titanosaur form, back to diplodocid maybe. Now a non-titanosaur symphospondyle.
It really underscores how tricky classification can be, especially, as we said, with limited material. Each analysis uses different methods, different comparison groups, and can arrive at different plausible results.
It's a fantastic illustration of science in action, though. Constant questioning and reevaluation.
Precisely. It's not that anyone was necessarily wrong before. It's that our understanding evolves as we get more data and better tools.
Okay, so given all this uncertainty about its family ties, can we even say how big Australodocus was?
People have tried to estimate, yes. Gregory S. Paul, a well-known paleo artist and researcher, gave it a shot back in 2010.
And what did he reckon?
Based on the vertebrae, he estimated a length of around 17 meters, that's about 56 feet.
Okay, decent size.
Yeah, and a weight of maybe 4,000 kilograms, which is roughly 8,800 pounds. So a respectable mid-sized sauropod, but certainly not one of the true giants we sometimes see from Tendaguru or elsewhere.
Still pretty big by today's standards. Okay,
Yeah.
let's try and pull the key points together for everyone listening. What are the main takeaways for Australodocus?
Right, so key facts. It lived in the late Jurassic, around 150 million years ago.
Got it. Late Jurassic.
It was found in Tanzania, in that crucial Tendaguru formation.
Tanzania. Check.
Its classification is, well, complicated and debated. It started as a diplodocid.
Because of the forked spine.
Right. Then suggested to be a titanosaur form.
Maybe related to Brachiosaurus?
Then potentially back to being a diplodocene diplodocid, or perhaps a non-titanosaurus symphospondyle, maybe related to euhilopodids.
Based on that spongy bone structure and other features.
Exactly. And all this debate stems largely from the fact that we only have those two neck vertebrae.
That limited evidence is really the key constraint here, isn't it?
It absolutely is. It highlights the challenges, but also the excitement of paleontology, how much we try to glean from so little and how interpretations can shift.
Well, we definitely went deep on Australodocus today. We set out to understand its story, its discovery, and these classification changes, and I feel like we've got a much better handle on it now.
I think so. It's a complex but a really fascinating case study in how paleontological science progresses.
So here's a final thought for you, our listener. Considering this whole journey, this back and forth based on just two bones, what does it really tell us about the challenges of knowing the deep past? And, maybe more excitingly, what kind of future, maybe another bone from Tendaguru, maybe something unexpected elsewhere, could finally settle the identity crisis of this intriguing southern beam? Something to ponder